Good morning, Srini. Have a good night rest.
Hello.
Yep, morning. Have a good night
Morning.
rest.
Yeah.
Anything you want to clarify?
No, not yet. Teacher,
Yep,
good news and bad news.
yep. What's the good news?
Good news is they delayed the term 3 paper.
Delay the physics paper again, ah?
No, everything.
Oh, why do they need to delay for what?
That's why I also don't know lah. This jokers
Funny lah,
lecture.
this education ministry. You
Yeah
affect
lah, that's
all.
why.
You affect the university entrance, all that. Cannot keep on simply delaying.
No lah, but delay, I think maybe 1 or 2 weeks like that lah, they delay.
Okay, let us carry on. You go over oscillation. What are the things you need to remember?
Okay.
Okay. Usually we start with the oscillation here at B. Then your phi is 0. Phi is a phase angle. Right? It goes from B to C to A. This is free oscillation, no air resistance. Then this is the symbol for amplitude. And that's the definition. You must know that. Right? What does the negative sign stand for? And how to draw the graph. Right? Negative slope. The gradient equals to that. Then the velocity distance displacement graph is a ellipse. And then to derive that, you must replace your acceleration with that. Right? That. And then you can derive that equation. Okay, your V naught is same as circular motion, R times omega. Acceleration is V naught times omega. And remember that total mechanical energy equals to kinetic plus potential energy. Then total energy, right, depends on amplitude only, and omega square. Right? And easiest way to remember is remember a spring. No? Potential energy stored in a spring is your potential energy. If you want the actual equation, that's the actual equation. Right? Can derive from here. Half mv square this one, and I can deduce that this is a formula. And that is the energy displacement graph. That's the total energy. It's constant for free oscillation. And then this is a potential. So that's why it's of this case. And this is the other one. Okay, and that equation can be written as that. And this is the solution to that equation. This is also solution for this equation. So we are using this equation most of the time, which is this one. Right? Doesn't mean that we cannot use this one. If we use cos, it's going to start from here. C. So if we sign that is the graph, that's the amplitude. Right? Amplitude is constant. And then velocity, you just differentiate that. Get your velocity. Right? And then V naught is x naught omega. Acceleration, just differentiate. Right? Just understand the phase difference between these two is 180 degrees. Right? Between these two is 90 degrees. Okay, and if you like, V leads displacement, velocity leads displacement. And then for spring, minus kx, and that is your period equals to pi m over k. And then normally the general equation is that plus your phi. Phi tells us where you start the oscillation. So if you start from C at time 0, then your phi will be what? Yep. What will be the value of phi? And remember, if I start my oscillation from C, Yep. What is phi? What is the phase? These are basic things you must know. Right? We start from 0. 0 here, 90 here, 180, 270, 360. Right? So if it's 90, it's here. If it's pi is here. That means going to the left, not going to the right. Right? That one, all this information must be there. And then the period is 2 pi over omega. Frequency is 1 over period. Then for simple pendulum, that's the equation that you need to remember. And then this one does come out where the spring constant is K. Right? It's still the same equation, except that this K, you have to replace it with 2K. That means you add this K and K together, you get 2K. So the effective spring constant is 2K. Right? K is the spring constant for each of them. And then you need to know your force oscillation and resonance over them or lightly them. Right? Sorry. Yeah, number 1 is over them. And critically them also, I think they are very poorly drawn. It should go to 0 here. Okay, sorry about that. It should go to 0, not go to infinity like that. Right? Critical them should go down. So this one is wrong already. Lightly them, right? Or under them, lightly them or under them, the amplitude will decrease. And then this is resonance or force oscillation, amplitude against driving frequency. Right? The resonance frequency and natural frequency must be the same. Right? That one is heavy them, least lightly them. Right? If we observe multiple choice, you cannot escape. There is either 2 or 3 questions, except geometry optics are not that popular. Sometimes 1 question only. Okay, then we look at others. Right? For B and C, this one seems to be quite popular. Wave optic, and then quantum physics, more like only this year don't have, more like every year, either A or B, same like here, right? Every year. That's all we can say, which is popular. Okay, any comment? Trini, are you with me? I think you better turn your video on so I know.
No, chill. I'm actually here. I actually accidentally unmute just now.
You're
That
not
means wave
responding to
optic.
me, so I don't know sometimes what happened or it will disappear.
No. Wave optic and quantum physics commonly ask. Oscillation very rare. They ask the essay lah. So that means even
It
for
still does come out, either B or
yeah,
C,
but yeah,
right? Not that popular. It
even
just
wave
come out
motion also.
irregularly. Right? Section A, as I say, always got about 2 or 3 questions. Right? 2 questions. Most of them 2 questions. Can't say much. Right? Can't say much. Kinematics and this one, damn oscillation. Right? At least 2 questions every year. Okay, what's the answer for this one? A particle performs simple harmonic motion. Which graph shows the variation of
Donkey,
acceleration?
donkey.
Donkey.
Hey, boy. Sorry, boy.
You don't know. We are lost. That's the basic one. Acceleration is the definition. Which graph shows the variation of acceleration of
Hey,
particles?
see. Sorry. See.
You're not sure. You simply guess only. This is for velocity. This is for potential energy. This is for acceleration time graph, not displacement. So answer is A. Right? That's a definition that you must remember. Okay, any comment? Okay, a particle perform simple harmonic motion.
Yeah, check. Go back a bit. Okay.
Okay. A particle performs simple harmonic motion along the y-axis according to the equation that which statement is true of the motion of the particle?
Donkey.
Donkey. Acceleration of particle is always directed away from equilibrium. Oh? A is wrong. The value of k does not depend. Oh, A is correct. K is constant. It doesn't depend on where you displace a particle. Period of motion depends on y. No, not true. False. Period depends on your k or omega. In this case, you should be able to say that your omega square equals to k. The velocity of the particle is directly proportional to y. Right? Velocity is not directly proportional. Right? You can see the equation. Acceleration particle is always directed away from the equilibrium, no? Directed towards the equilibrium position. That is important to know. The answer is A. Okay.
1 minute, sir. Okay.
Okay. The displacement x of the object varies with time when it oscillates with simple harmonic motion is shown in the graph. So that's the displacement time graph. Which graph shows the acceleration of the object varies with time? Why it take so long?
Donkey, sir.
Yeah, 180 degrees of phase. It's always anti-phase to each other. Right? Always oppose each other. That's why it must be the same, exactly the same sine graph, but it's inverted. That's all. Donkey. Which is the velocity time graph?
Velocity time graph.
Yeah.
I think it's the A, teacher.
Yeah, A. Just differentiate it. Right? Differentiate that. You get a cos graph. This is a sine graph. Differentiate become a cos graph. That's your A. Velocity time graph. Okay, this one need a bit of calculation. A particle performs simple harmonic motion.
Check, go back again, sir. Okay.
Okay, let's go to the next one. I need to calculate. No, the basic. Particle performs simple harmonic motion with amplitude A. What is the maximum velocity of the particle to complete an oscillation in time t? Yeah.
A, teacher.
Okay. That's your frequency. Number of oscillation divided by your time. omega is 2 pi f. Right? 2 pi, and replace your f with that. That's why you get that. And your maximum velocity is your amplitude times omega. Put this one into the equation. Right? So in this case, they use A for amplitude rather than x naught. Replace the one with that, and there's your omega. Answer C. Don't guess. Work it out. Okay, number 5.
Okay, go back, Jay. Wait, Jay, the x naught is A over T, is it?
What x naught are you talking about?
Oh, the x O, it's A lah.
X naught is the
basically, right, Jay?
amplitude. This is the amplitude.
Mm.
A.
Okay, good.
A bob of simple pendulum is displaced and then released. The displacement of the bob after time t is given by the equation. What is the shortest time? What is the shortest time when the kinetic energy of the system is equal to potential energy?
These are not sure, Jay.
Right? Go to the equation. Unless you can memorize the equation for kinetic and potential energy, go ahead, use that. If not, work it out from velocity. So that's your kinetic energy, half mv squared. Right? Half m, then square this one, that's how you get that. Then your potential energy, right? This is the total energy. So that must be the potential energy. That one. So we get it out there. So you want the two of them to be equal. That's all. Them equal. Cancel that part there. Cancel this part out there. So we got your a squared minus x squared equals to x squared. Right? Take this minus to the other side, you get your 2x squared equals to a squared. Then square root it. X equals to a over root 2. Right? Your a is 0.5. A is 0.5. And then root 2. That's the original equation. You want to find the time now. Pi t equals pi over 4. Okay, for this one, you want cancel your 0.5. Okay. So 0.5, you know that 1 over root 2 equals to pi over 4. Yeah, 1 over root 2, cos 1 over root 2 is, you cannot see that.
What?
1 root 2 triangle, 45 degrees. Let me just CO cos right? That one you must know. That's your mass. You know, use your calculator to calculate all. You forgotten all your. Okay. What we do is we cancel the 0.5, 0.5, and this 1 over root 2. 1 over root 2 is cos pi over 4. So pi over 4 equals to that. And you can cancel the pi, take the 2 down, and calculate out. Can? Yep. What is the problem? Any part not clear? First, we calculate where the displacement is the same. Right? First, we calculate the displacement where the kinetic energy and potential energy is the same. That's what we are told. And after that, we use the equation to calculate the time. Yeah. Which part is not clear? Ask. Don't keep quiet.
It just, but then the 0.5 cos 2 pi t equals to 0.5 square root.
This 0.5 and 0.5 cancel. Then you get 1 over root 2. 1 over root 2 is just that. That's all. 1 over root 2 is cos pi over 4. So that's why we get pi over 4 equals to that one, 2 pi over t.
Oh, okay. Understood.
Then the others are just using your calculator. Okay. The graph of displacement S.
Go back again. Okay, thank you.
A graph of displacement S against time of a body performing simple harmonic motion with period T is shown in the diagram below. Which graph shows the variation of kinetic energy and potential energy of the body with time? What's the answer?
I'm not sure, actually. This one looks confusing.
Very good, confusing. First thing, there's your displacement time graph. And as I said to you, you just remember your spring. When you work with displacement time graph, remember your spring, R K X squared. So I square this one, maximum. I square this negative, become positive. So I square this one, I get positive. So if I look at potential energy, I should see for this period there, I should see 1, 2, 3 peak there. So I look at potential energy graph. There's a potential energy graph. 1, 2, at the period T, 3. So answer is A. And kinetic is the other way around. That's all. Yep.
So you have to start from potential first, is it?
Because you are given displacement. Then you start with potential.
Oh, okay.
You just square that. Square that. 1 peak. Square negative becomes positive. And square that becomes positive. So 3 peak for this from 0 to T. Then look at the graph there. Then where the potential is maximum, kinetic is 0. That's all. Okay.
Right. Okay.
An object of mass m oscillates at the end of a spring with constant k. If the amplitude is a, what is the maximum speed of the object?
C.
Okay, let's see. Right? The period, you must remember the formula, and it's equals to 2 pi over omega. So omega, right? 2 pi and 2 pi cancel, cross multiply, take this one down, you get inverted. Then know your maximum velocity, amplitude times omega. Replace the A with that. Replace the omega with root K over M. Donkey. Okay.
Okay.
A mass of 25 grams is hung at the lower end of a vertical elliptical spring with a force constant of 2.8 Newton per meter. The mass is pulled down, then released to undergo vertical oscillation. What is the additional mass required so that the period of the vertical oscillation is 0.7 knot second?
Boy.
Go to the basic formula for spring. Right? Given the mass there, you are given the spring constant. That's your spring constant. That's your period. So for the initial case for this mass, the period is that one there. And then I don't like to work with numbers. So I take all the constant. Right? The mass is the one changing. K is constant. 2 pi is constant. Right? So I square that. Take the M down. That's all. Constant I take to one side. Don't bother about the constant. Then this is the new one. Right? I'm just using this formula. I just inverted it and got M2 over T2 square.
Why you
M1 over
inverted
T1.
it, teacher?
Say again.
Why you inverted?
I want to find M2.
Oh,
I want
okay.
to find period.
Hmm.
So I invert it as still a constant. It doesn't matter. Then I want to find M2. Take the T2 square across. That's what I get. Then put in my value. Right? That's my T1. Right? That's your 25 initial mass. 25 gram. It doesn't matter as long as you use the same. You use gram, you will get gram. Right? The period T2 is given you 0.7. And T1 we have already calculated. There. So you get 34.8. Right? This is not the answer yet. You want additional, so it's a subtract. 34 minus 25. So answer is B. Ken, anything not clear?
Oh, so that means the additional mass is 34.8. You want to find the you want to find like difference lah.
I need to subtract from the original mass to find the additional mass, that's all. Right? So this is not the answer.
Okay.
This is not a new mass, which is that donkey. You want additional mass, so you have to subtract.
Okay.
An oscillating spring mass system is under damped. Which graph shows a variation of displacement with time for the motion?
C.
Okay. Under damped.
What's up?
Under damped is C.
Yeah. Hey, boy. I'm sorry. Boy.
B is over damped.
Under them is boy. Silap.
Right? Under damped is boy. This is critically damped. Right? You must be able to recognize that. Right? This is undamped.
That means no impact lah.
This is under damped. Right? No air resistance, no friction. And this is heavily damped or over damped. This is critically damped. That's all. An external force is applied to a damped oscillating system so that the system could oscillate continuously. Hence, to maintain the maximum amplitude of oscillation, the frequency of the applied force is
Boy.
no, it must be equal. Right? If
Not double.
your
Answer.
brother or sister sitting on a swing, you must have the same frequency as a swing. Then your amplitude will keep on increasing. Resonance occurs when the frequency of the external driving force equals to natural frequency. C. Okay.
Where answer? Okay. The next question, sir.
Which statement is not true about damped oscillation?
C is correct. B is correct. A and D, I'm not sure, but wait, answer.
What's the answer then?
A, the answer is A.
Which of the statement is not true about damped oscillation? Damped oscillation, energy is lost. In all damped oscillations, some of the mechanical energy is lost as heat. That's true. In an over damped oscillation, the object oscillates for a very long time. No oscillation. There is no oscillation. It just takes a long time to go back to zero. Right? So this is false.
But very long time what to get to zero?
Yeah, there is no oscillation.
Oh.
No oscillation, sorry. Poor English. In overdamp, there is no oscillation. The object takes a long time to go to the rest position. In underdamped oscillation, the object oscillates with decreasing amplitude. That's correct. In critically damped oscillation system, the object moves to the equilibrium position in the shortest possible time. That's correct. Right? It doesn't oscillate. It just returns to the rest position a quarter of the period.
Check, go back, check.
Okay.
Okay.
A pendulum with natural frequency F1 is driven by a periodic driving force of frequency F2. Which combination is true for resonance? Open to the amplitude and frequency.
C.
Amplitude is maximum. Frequency is the same. A. That's a basic you must remember.
Every time when resonance comes,
yeah, frequency of driving force equals a natural frequency. Remember when you push a swing, your sister sitting on the swing, you must have the same frequency as that. If not, you will miss or you will decrease amplitude. So every time you come, you push. Every time you come, you push. Every time the swing comes to you, you push. The frequency must be the same.
Or over them, like overdo it.
What over them? There's no over them here. Over them only affect the graph only. The amplitude of the oscillation, that's all.
Okay.
Okay, let's look at B and C. Right? You can see there, some years they don't come out at all. Right? Some years it come out as B, some years it come out as C. Right? They won't repeat. If it's B, then this is B, then this one will be C. Right? They won't repeat there. Does not come out every year. State one characteristic of simple harmonic motion. Yep.
The one characteristic of simple harmonic motion is acceleration is directly proportional to the displacement from equilibrium position.
Okay, acceleration is directly proportional to the displacement
But
from
in
the rest.
opposite direction.
Yep. Only one mark. So it can be amplitude constant, or can be acceleration is directly proportional to displacement from the rest position, or acceleration is always opposite to displacement. Okay, the oscillation of simple pendulum is given by the equation where x is the displacement in centimeter, t is the time in second. Determine the frequency of oscillation.
Um, (3.0 over 2 pi), which means the answer is 0.477.
Right? Compare with the standard equation.
Yep.
Then you know what is omega.
F equals to omega over 2 pi.
Then omega is 2 pi f. F is omega or 2 pi. Put in your equation. Okay, good. The oscillation of the oscillation. Okay, you have determined number one. Calculate the speed of the pendulum at time t equals 0.4. This one is straightforward lah. You have to make sure that you know that the calculation is in radian, not in degree.
So this one, you use that formula V equals to A omega, right? So,
No need to memorize formula, just differentiate only. Just differentiate only and put into the equation.
oh.
Yeah, omega, you already know. You know the frequency. So differentiate it. That's all. Then put into the equation. Okay, answer. Yeah. Determine the length of the simple pendulum. How to do that? The one you need to memorize the equation.
Teacher, the 0.4 is from the frequency, right?
I differentiate this one. It become a cos graph. Then take the 3 down there. That's why I get 2.4 times 3. And then there's your 3. Then the time is 0.4. Put inside there.
Ah, okay.
Yeah, how to calculate the length of the simple pendulum? Yeah, just calculate your t is one of the period. The frequency is just that. And then there's the equation. Depend on how you memorize the equation. Right? That's the way I choose it. And memorize in terms of omega, then you can use omega straight away. 2 pi L over G. Put in your equation. You want to find L, you square that. T square, 4 pi square. Then G take to the top there. Put in your value. 1.09 meter. Okay, anything that's not clear?
Clear?
Okay.
This is all using the right formula only lah. So,
you haven't tried the other one, try now. Number 2. While I go and switch on the power supply.
okay.
Yep. And get This one I derived with you in class already. It's
Yeah, the spring constant one, the formula T equals to 2 pi omega m over k.
the period, the block on a smooth table, the block is attached to two stretched identical spring. That means the K is a constant, which are fixed to the wall as shown in the diagram below. The mass of the block is 1.5, mass is given. The initial displacement is 5.0 cm. The effective spring constant for the combined spring is 25. Right? Effective, you add the K and K together, 2K. The block is then displaced 4 cm to the left and release. To perform a simple harmonic motion, calculate the period. That's all. For single spring, is F equals to minus Kx. Right? That's the acceleration. That's your period. So period for single spring is 2 pi m over K. Right? For that equation, you must know. Right? And you are told this effective, not one spring. That means the two spring combined together. I think that's where your answer went wrong. Right? Yeah, so I put a different color. So that is the effective. Right? It's still the same equation, except this becomes effective, becomes 2K. K is for one spring. So this one is given, not a K, K1. Right? So the same equation, put on there, and put in there, m over 25 is 1.5 knot. Right? Your book is wrong because your book consider that as 2K.
Yeah, it's actually 1k.
That's why I give a different answer. Okay.
1 minute, yeah.
Same equation as for single spring, except that you must remember that K is the effective spring constant. Means you combine the two together.
So the answer is 1.54 lah.
Yep.
Wait, but then like that means what you have to use the 2 pi m over k formula lah.
Same equation, that's all. Except this K becomes the effective spring constant. That means these two add together. That's why they give you this one. Not each of them. Each of them will be K. That's why your book go wrong. You use 2K. Here you use 2K. 2 times that.
Okay. So both springs combined lah, become
Both spring
1K.
combined is called effective spring constant.
Okay.
Maximum velocity of the block. Yeah, the period, you already got that. How to calculate the maximum velocity?
Omega equals to 2 pi over t, so 2 pi over 1.54.
Calculate out. And your maximum velocity.
4.08 second. Yes.
So you get 16.3.
So the x naught, why is it 4? Just not the 5.
X naught is 4. 5 is where you stretch it. This is the displacement. This is the displacement. This is where the string is stretched from initially.
The extension lah.
Yeah.
Oh no, because I was confused which one was the displacement just now.
A potential energy of system when the block is 2.0 cm from the midpoint. How to do that?
MGH.
Where got MGH here?
Potential
Half
energy.
kx square for the spring. Half effective spring constant is 25. Amplitude is there. Change it to meter. Okay. Okay. If you use the answer given by the book, then that's the answer.
No, I believe you answered because they did accidentally different.
Doesn't matter. If it's wrong, usually they will allow you error carry forward, so they won't penalize you as long as your calculation is correct.
Okay.
Okay. Can we go to the next one?
Yeah, can.
Define simple harmonic motion. Yep. 2 mark. Yep. You should be able to define for me. This should be on your fingertips.
Amplitude of oscillation is constant.
It is a to and fro motion where the acceleration is directly proportional to displacement and is always directed to the rest position. That you must remember. If you write in the equation, then you have to define each of the term. A simple pendulum consists of a block 200 gram. Let's just draw a diagram. That's the block, 100 gram, and length. That's your length. The bulb is displaced by 10 degrees with the vertical and release at t equals 0. So that is where you release the bulb. The air resistance is negligible. Show the bulb move in simple harmonic motion by considering the forces acting on it. Right? So these are the forces acting on it. The weight pulling it down, tension pulling it up, and then you have to resolve this force, right, into that one there. That one will balance the tension. And your T, your mg sine theta, right? That one is the one opposing. That's the one that gives the resultant force. Right? Put a negative sign because your rest position, your displacement is at 0 there. So this is opposite to displacement. That's why you get a negative sign there. Right? So consider the bulb displaced by a small angle of less than 10 degrees, or as I said, 10 degrees. L length of pendulum. Resultant force is MA, right? Equals to mg sine theta. You put the negative sign there if you want. Right? For small angle, sine theta equals to theta equals to x over L. Okay, this is your x over L. Then your acceleration, right? Replace that. M and N cancel off. A equals to, right? As I say, you have to put your negative sign there. Your theta, your sine theta equals to theta equals to x over L times your g. That's your g there. Right? So in this case, I put a negative sign because A and X are in the opposite direction. Right? A is going down. X is from the left. That's our rest position. So we have shown that G and L are constant. So your A is directly proportional to X and directed to the rest position. Negative sign there. That's all. Okay, any comment? Or anything not clear?
1 minute. There are. So why Bob displaced by small angle less than 10?
We want to use this approximation. For small angle, we can use this approximation.
Oh yeah, why sine theta equals to theta? That's why I don't get it.
Small displacement equals to tangent theta. Sine theta equals tangent theta equals to theta. That you must know. That's a fundamental for your math.
Or like every equation for small angle.
Yeah, for small angle, if you don't want to theta, then you can call it tangent theta. Same thing.
Oh, tangent theta is the same thing as theta lah.
Tangent theta equals to sine theta.
Oh, that means all of them are equal to each other lah. That means
it's just like a circle. Right? This is like a circle. This is like a circle. There's a radius. So your arc length S equals to R in this case L, R theta.
Oh, okay.
The equation of motion for the bob is that one, where X is the displacement, A is the amplitude, omega is the angular frequency, phi is the phase angle. Right? Calculate the value of A, omega, and phi. Okay, that's your A. You displace the bob. It's a triangle. That's your length, 1.5. Your theta is 10 degrees. So calculate A. Right? A is just 1.5 sine 10. That's your A. Right? From that equation there, compare with the general equation for simple harmonic motion. Omega square equals to GL. And put in your value to find your omega. G is 9.81, 1.5. Calculator. Get your answer. Okay. If you can guess this is 90 degrees, straight away you can get the answer. 90 degrees. Right? The rest position is here. So it displaced by 90 degrees, pi over 2. If not, work it out. That's your general equation. Right? T equals 0. The amplitude is A. Right? Put that one equals to 0. So your sine phi equals to 1. Right? A divided by A is 1. So 1 means your phi must be 90 degrees. Right? Determine the speed of the bob when the displacement is 10 cm. Right? Memorize the equation, that one. Put in your omega. That's your omega. Right? You put it in cm, then your answer will be in cm. Okay, your amplitude square. That's the amplitude. I put it in cm. That's the displacement. Okay, you can change the meter if you want to. It doesn't matter. Right? I use cm, so I get cm. Okay. Anything not clear?
Yeah.
State a difference in motion of the pendulum. It will be, it is brought to the moon. Just use the formula to, they ask you to derive the formula. Use the formula to argue out. Yep. Yeah, that's the formula. Omega square equals G over L. So on the moon, G is smaller. So omega will be smaller. Right? If omega is smaller, the maximum speed also will be smaller. Right? Maximum speed is omega times your amplitude. Right? So omega is smaller, your period will be longer. And describe that period is longer. Okay. Acceleration will be smaller. Right? G smaller. Maximum acceleration will be smaller. Okay. Anything not clear?
Wait, so moon is smaller, so omega will be smaller. That means everything will be small lah. Is it?
Depending on what you
Because
use to describe. You use period, and the period will be longer.
oh, okay, okay.
It's just all the formulas that you use. You can use that to describe your motion.
Okay, sir.
Number 2, an object is projected from point A and starts to oscillate in simple harmonic motion with amplitude 8.0 cm as shown in diagram below. At point A, the object is at half of its amplitude. The angular frequency is 20. Derive an expression for the motion of the object. Yep, Ken?
No, sir. How?
Yeah. You wonder how the displacement change with time? Right? That's the best way to describe the motion, how the displacement change with time. That's a general equation. Amplitude, so I'm using X in cm. And then omega yato 20. Only time and phi we don't know. So at 0, you are told that at 0, this is halfway. You can put 4 there. Right? This is 0. So you got sine phi. You can calculate your phi. So phi is half. Right? 8 divided by 4. Half. Half is right? You should know your half. Half is 30 degrees. 30 degrees is pi over 6. Okay. So your phi is pi over 6. Can write a general equation. Yep.
So t equals to 0 and then 4 equals to the thing, then sine theta equals to sine pi over 6.
Half. This is half. 4 divided by 8 is half. Half is 30 degrees. It's sine 30 degrees. Sine 30 degrees is pi over 6.
No, because on the left side there is a sign, then how come right side another sign? That's why I'm a bit confused.
This one is 4 over 8. 4 over 8 I replace it with sine pi over 6. Pi over 6.
Oh, cannot like that. Okay.
Well, cannot. This is maths. Half.
No, maths they
half.
Yeah, I know, but I never convert like sine pi over 6 or like didn't even have
Half
to
is
do like
30.
that.
Sine theta equals to half. Half is that theta must be 30 degrees. So I'm changing 30 degrees to pi over 6
Oh,
to help you see
okay.
the problem. The answer straight away.
Okay. Understood.
Right? Calculate the speed of the mass at 2.5 cm from equilibrium. You can see that they want you to remember the equation. Oh, calculate the period first. Calculate the period. Right? First, you calculate the general equation and calculate the period. Your mass is given. That's your mass. That's your spring constant. So that's your period. Then calculate the speed. 2.5. So calculate your omega first. And use the equation. Put in your value. Right? That's your omega. Amplitude. Amplitude is 6. Right? Amplitude is 6. I use in cm. Then yeah, tau 2.5. You got 2.5 there. Calculate out. I change it to meter here. This is in cm.
Yep.
Kinetic energy of the mass at 3.5 cm from the equilibrium. It make life too difficult for you lah. Have to calculate again, no?
1 over dx square.
Calculate velocity again. And half mv square.
Half mv square.
Right? 0.5. And there's your v square. In joule. Okay. Anything that's not clear?
Clear. That means the third one, that means they replace the 2.5, 3.5 lah. That's the trick lah.
Yeah,
Right.
just
You
repeat
cannot
the
like
equation
straight use
calculation, that's all.
the
Instead of 2.5, you use 3.5. Calculate the velocity or speed. And then you want joule, then you convert that to meter. Right?
Yep.
That's the velocity. The mass is given, that's the mass.
Understood. Understood.
If the horizontal surface in B is not smooth, describe the change in motion of the mass. Yep, what's going to happen? 3 mark. Make sure you got 3 solid points.
Friction causes damping to occur.
There's only 1 point.
Yeah, loss of energy causes decrease in amplitude. Mass stops oscillating.
Right? Energy of oscillation is lost as work done against friction.
Yes.
So if energy is lost, then the total energy decreases. So amplitude of oscillation decreases until finally it stops oscillation or stop oscillating. State whether it is possible for the damped oscillation to occur while the system is in resonance. Give your reason. Yep.
Not possible. Because system oscillate with maximum amplitude and amplitude is constant.
Why not possible? Force oscillation, you can still damage it. You can still damage, just like you push a swing. If there's no air resistance, the one sitting on the swing will fly out. Because air resistance, that's why it stop you from the swing stop, the amplitude will become maximum. You have to use more and more energy to push your sister sitting on the swing. Yes, our swing can be damped. As resonance is the amount of at resonance, the amount of damping determines the maximum amplitude. Yeah.
Actually, the book give different answer.
You must think through lah. Don't always accept the book freely. Right? If it's wrong, it's wrong. Refer to what is the basic teaching. Go to the basic. That one there. This is false oscillation. This is light damping. This is heavy damping. The amplitude becomes smaller, that's all. Okay?
Okay.
Sometimes we make mistakes. I also sometimes do make mistakes, so you must try to think through. Okay? It can damp, it can be damped. You just determine the maximum amplitude, that's all. Just like you push a swing, sister sitting on it. If there is no air resistance, you will fly over. Right? Because of air resistance, you have to put more work in to push to higher and higher amplitude. But you will find that it's becoming difficult and difficult because you don't have the more strength to give more energy. Can we have any question to ask? If not, we will call it a day. Friday we go to topic 2, and if you can go topic 3, we are too slow already.
Yeah, okay, sure.
No question to ask.
No question to ask. I can understand better now.
Okay, if no question to ask, we'll call it a day. Unless you have anything else you want to talk about.
No, okay. But the exam delayed lah, so the means can
You just let me know when is the actual date.
Okay, can.
Okay.
Thank you,
Have a good day.
then can have class on extra class on Tuesday,
You want Tuesday another class?
Yeah, 3:30.
3:30. Okay. Tuesday 3:30.
Okay. Okay. Thank you,
Okay. Have a good day.
Good day, Thank you. Bye.
Bye bye.